In this segment, we'll talk about the LU decomposition method. We'll do that through an example. So here is an example. We're asked to simply solve this set of equations right here. We are given the LU decomposition of the coefficient matrix. This is our lower triangular matrix. This is the upper triangular matrix. So it's already given to you. If you want to figure out how we do the LU decomposition of the matrix itself, go to the video description and you will see a link there. What which we need to do is let's first recall what LU decomposition is. We have AX equal to C. We write our A in the LU form, and then we say, hey, we got to first solve L times Z is equal to C, and then we got to solve U times X is equal to Z. So this becomes our first set of equations. This becomes our second set of equations. And once we find Z here, we put it back in here, and then we can find X. So let's go and take this first part separately and this second part separately. So what we have is a set of equations in the matrix form, which looks like this. So you can see that the coefficient matrix is a lower triangular matrix, and our right hand side is the same as the right hand side of the original equations. So we get the form of L times Z equal to C. And what we need to apply is something called forward substitution. And the reason why we're doing forward substitution is because we can see that the first equation has only one unknown, which is Z1. The second equation has only two unknowns, Z1 and Z2, but we just found out Z1, so we can find Z2. The third equation has three unknowns, but we already just found out Z1 and Z2, so we can find Z3. So that's the beauty of the forward substitution or back substitution, as you must have seen in your naive Gauss elimination method. So if I look at the first equation, that is just Z1 is equal to 106.8 because it's 0 times Z2, 0 times Z2, and 0 times Z3. Let's look at the second equation. We have 2.56 Z1 plus Z2 plus 0 times Z3, so I don't need to write that. So I get 177.2. From here, Z2 will be 177.2 minus 2.56 Z1. So I just found out what Z1 is, which is 106.8, and that number turns out to be minus 96.208. Now let's go and look at the last equation then. We'll have 5.76 Z1 plus 3.5 Z2 plus Z3 equal to 279.2. We just found out Z1 and Z2. We found out Z1 and Z2, so we can find what Z3 is. So we'll rewrite the equation for Z3. We get this. And now we can substitute the values of Z1, which is 106.8, and Z2, which is minus 96.208. So having said that, we'll be able to find out what the value of Z3, which is 0.76. So we have found out what the Z vector is at the end of the forward substitution steps, and we find Z1, Z2, and Z3 to be equal to 106.8 minus 96.208 and 0.76. So what we have to do now is we have to do the back substitution part. So that's back substitution. We already know what U is. We just found out what Z is, so we can find out what X is. So if we write down our equations for ux equal to z, this is what's going to look like. So let's write down what the U matrix is, the upper triangular one. Multiplied by our unknown vector x1, x2, and x3. And here I'll have 106.8 minus 96.208 and 0.76. So what we're going to do is in the back substitution, we start with the last equation first. So that gives us 0.7x3 is equal to 0.76, because it'll be 0 times x1 plus 0 times x2 plus 0.7x3, which is right here, equal to this quantity. And that gives us x3 is equal to 0.76 divided by 0.7, and we get 1.0857. Let's look at the second last equation. And we'll get minus 4.8 x2 and minus 1.56 times x3 equal to minus 96.208. There's no x1 term because we have a 0 here. And what does that give us? So if we write down what x2 is, and we write it in the same form as we would be doing it if we were doing this through a computer program. So that's why I'm taking things to the right side and dividing by the coefficient of x2. So we get this quantity right here. And this number here turns out to be equal to 19.691. So let's go and see what do we get from the first equation, which is right here, which will have all the unknowns. But at the same time, we already know that we have found the other unknowns except for x1. So I'll write down x1, or write down the equation in terms of x1, because that's the only unknown. And now we substitute the values of x2, which we just found out, and x3, and this number here turns out to be equal to 0.29048. So we have basically found out what the solution is. The x vector is x1, x2, and x3, and that turns out to be equal to the following numbers. So we have found out x, and that's what how LU decomposition method works. And that is the end of this segment.